Today's lesson, proofs with parallel lines. Yesterday, our lesson was about if we have two lines that are parallel, cut by transversal, corresponding angles are congruent, alternate interior angles are congruent, consecutive angles are not congruent, supplementary, alternate exterior angles are congruent. So if the parallel lines, if the lines were parallel, then those things were true. If they're not parallel, it's not true anymore. You take one of those lines and change its slope different from the other one, then that stuff wasn't true. But today we're looking at the converse of that. If this is happening, then, so if the corresponding angles are congruent, then the two lines cut by transversal are parallel. So what does that look like? This is yesterday, this will be today. Yesterday, if this was going on, then corresponding angles are congruent. If these two lines are parallel, then corresponding angles are congruent. I just picked one pair, not all of them. If this is going on, then alternate interior angles are congruent. If this is going on, I'm going to skip the consecutive part and come back to it. Alternate exterior angles are congruent. If these two lines are parallel, then this angle is supplementary to this angle. There's no way to really show that on this figure, but they are supplementary. They add up to 180. But we can go ahead and show this. All this is going on if these lines are parallel. Today, we're saying if you have two lines that you don't know are parallel, cut by transversal, if you know that corresponding angles are congruent, if you know this, then you know that the two lines are parallel. So it's the converse. If this, then this. If this, then all of this. So if you know any of those things about the intersections of the parallel lines cut by transversal, then you can determine that they're parallel. Is that pretty clear? Okay, good. So, the problems that you'll be working in this section will look just like yesterday's, except for the directions read differently. But the way you work them will look the same, but you're really not doing the same thing. Yesterday, in your problem, the two lines had the little triangles showing that they're parallel. And then you would go, okay, well, if those are parallel, then these two are corresponding and they're congruent. So then I can find x by setting them equal to each other. Well, today, we don't know that these lines are parallel, but for what value of x would make these two lines parallel? So I have to figure out the one number that will plug into x and give me the number here, which would make these two lines parallel, which means this would have to equal 135 degrees, because these two angles would have to be congruent to make these two lines parallel. So if they're corresponding angles would have to be congruent for m and n to be parallel. So all I had to do is set 2x plus 15 equal to 135 to see what value of x would make those two lines parallel. So let's check it and see. If I plug 60 in for x, I get 2 times 60 is 120 plus 15 is 135. So if this angle is 135 and this angle is 135, then M and N will be parallel. I can plug in any number I want to for x, but there's only one number that makes the two lines parallel. Number 8. These are alternate interior angles, and they have to be congruent to make M and N parallel. So same kind of thing. 3x has to be equal to 2x plus 20. The difference here is that we know the measure of this angle, it's 135. Here we don't know the measure of either angle, but it doesn't matter. You still set up your equation the same way. You set the two things equal to each other. Subtract 2x from both sides, you get x is equal to 20. All I have to do in both problems is find x. But in problem number 8, if I was curious and wanted to know the measure of the angle, I could just plug it in and see. Plus, I could check my answer to see if I get the same thing for both. If I plug in 20, I get 60. If I plug in 20 here, I get 20. 2 times 20 is 40 plus 20 is 60. So I would get 60 for both. So that would be a way on your test to check how you can check your answer and make sure you did it right. Yes? You're just thinking of them differently, I hope. Because yesterday you're told that these two lines are parallel. What is x? Find x, which means they have to be congruent if these two lines are parallel. Today, what value of x makes them parallel? Well, they have to be congruent to each other. So the problem looks the same, the directions are different, and you're actually doing something different. It just doesn't seem like it. Mm-hmm. So that is why I don't have many examples for your homework today. And I think you'll be okay with that. Any questions about any of that? Make sure you write down to exclude number 9 and 10. I'm not doing 9 or 10, but you're doing 3 through 25 odd, 41 through 44 all. If I don't put odd, that means all.